Hello everyone, my name is Chirag Patil and welcome back to my YouTube channel. So in today's video, we will understand how linear regression works, right? So let's start. So first of all, in a regression, we need to predict a y which is any real number, right? While in classification, we have defined classes like 0 or 1, but in regression, we need to predict a real number, right? So let's take an example. I have one variable x and I need to predict y. So let's say my x is a number of square feet, right? Let's say x is square feet and my y is house price, right? Let's say house price, right? So in linear regression, we will find a best fit line which will reduce my error, right? And what will be the error? Error will be the actual house price minus predicted house price, right? So let's say I am I found this line, right? And here, so basically in regression, how we can find y based on x? So we know that line equation would be, let's say, w transpose x plus b, right? Right, w transpose x plus b. So we just put x here and we will receive the y. So for here, if you see, for any given x, let's say this x, right, I will find a y here, right? This y value will be predicted for this given x. Let's say I just have only one variable, then this is the case, right? Okay, so let's say if I am predicting value here something, right, and actual value is this, then this is my difference between actual price and predicted y, right? So we need to minimize the difference between actual and predicted. So I can rewrite this like, let's say our target is find w which will minimize I is equal to 1 to n yi minus yi hat, right? Where yi hat will be our predicted value and yi is actual value. Here, now what will be the yi hat here? So if you see, yi hat will be w transpose x plus b, right? So if I rewrite this equation, we can say find the optimal w which will minimize sum of I is equal to 1 to n yi minus w transpose xi plus b, right? Okay, so if you see here, let's say I am predicting yi here, right? And my actual point is here. Okay, so what will happen? My yi hat, sorry, in here, my yi hat will be greater than my actual y, right? Here, if let's say point is here, actual point is here, and I am predicting this, right? Then yi hat would be less than my actual y, right? This is the case because we are predicting on this line, right? So if you see here, this can be negative and positive both value, right? But we are taking sum here, so it will affect our optimization function, right? Sometimes we will receive negative and sometimes we will receive a positive value here. So for simplicity, we are adding a square here, so we do not care about whether we are predicting higher value or lower value, but our target is to minimize that error. Or let's say the best model will provide yi minus yi hat is equal to 0, right? Okay, so this is the optimization equation for linear regression, and this error yi minus yi hat square is also called as a mean square error. Okay, so this is also called as a mean square error, right? So now in this equation we can also add a regularizer term, right? So let's add, let's say w star is equal to w star find optimal w, which will minimize sigma I is equal to 1 to n yi minus w transfer xi plus b square. Let's add regularizer lambda times norm of w square, right? Basically L2 norm, right? So if you see this equation, we are just adding a regularizer. This will called as a loss and this will be called as a regularizer, right? So why we would require a regularizer in linear regression? So it will help us to minimize our weights, or I would say find the optimal value of weights. So our weights will be contains a lower value. So if I say in an example term, so let's say hypothetically, we know the best line, right? What is the best line? So let's say my best line is, we are just defining like w1 x1 plus w2 x2 plus b, right? This is our line equation, right? Y is equal to, let's say. So for example, my actual value is, let's say 5x plus 7x2 plus 3. This is my actual line. We know the best fitted line. Let's say hypothetically, let's say actual best fit line. And now let's say I predicted one line without regularizer, then it would be like, let's say 5.1 into x1 plus, let's say 7.2 x2 plus, let's say 3.1, right? Without regularizer, I would say. And if I predict a new line with regularizer, then my weight could be x1 plus, let's say 6.99 x2 plus 3.001. I can find the weights which are lower in the value, right? We are not saying like we need to minimize too much, but we need the best value near to our actual y, right? So this will help us to achieve this. This will also not impact much on the error, but we will find the better reducing error with this regularizer, right? So that's why we would require a regularizer. And this is, let's say, a L2 regularizer. We can also use L1 regularizer as well. So here we are taking a square, right? So if I say L2 regularizer, it will be like W1 square plus W2 square plus W3 square, right? And we can use L1 as well, which will use the absolute value of W1. Let's say absolute value of W1 plus absolute value of W2 plus absolute value of W3. This is called as L1 regularizer. So you can use L2 or L1, right? And if you use both, let's say L1 plus L2, then it will call as a elastic net regularizer. Elastic net regression, you can say, right? And we learned that for if L2 regularizer, we use L2 regularizer, it will help to get lower value of W, right? And if you use L1 regularizer, it will create a sparse W, sparse, right? That means the weights which are associated with the feature which are less important, they will be 0, right? So let's understand what is the feature importance we are talking, right? So let's say I have two features, right? Let's say x1 and x2 is my feature, right? And what we are doing w1 x1 plus w2 x2 plus b, right? Y is equal to, so if you see this equation, right, x1 and x2 are coming from our training set, right? And W1 and W2 we are finding. So if my W1 has larger value, let's say larger value, right? It could be negative or it could be positive as well, right? So we can say to predicting why my W1 is providing or giving more weightage, right, to x1. Let's say my W1 is equal to 5 and my W2 is equal to 1, right? So if you calculate this equation, right, who will impacted much with W x1, right? So we can say while predicting y that x1 is a good feature than x2 or x1 is better feature, right? So we can say x1 has more feature importance than x2 because we get a weight associated with it is larger, right? Same. So if you apply L1 regularizer, then you will find this W1 will be the 5, right, say, but W2 will become a 0 or near to 0 value, right? So we can get feature importance from them as well, and the which features which are not having the good importance will be weight associated with them will be near to 0. This is the benefit of L1 regularizer, right? So this is all about regression or linear regression, right? So linear regression also known as a least square method because we are using linear plane here and taking mean square error here, right? Okay. So if you have any doubt related to linear regression, please comment it down. I will discuss there, right? And if you like this video, please press like button and subscribe my channel and share it with your friends. Thank you.